Okay, welcome back. In this video, I'm going to discuss k-means clustering, a very famous, very popular algorithm for clustering, unsupervised learning, a simple model, but very useful model, used a lot. So the idea is the following: because we are going to cluster, the target label will no longer be available. So let's say again we have feature x1 and x2, and it has a lot of values. I mean, feature 1 has a lot of values. Feature 2 has a lot of values. And let's say we know that, or let's say we want to group or we want to cluster this data, let's say into maybe 3 different groups. Let's say the value of k is 3. So here k is the number of groups. So how can we group this data into 3 different clusters? How can we group them together? Well, k-means offers a very simple formulation for this. What the algorithm suggests is the following: you actually pick some initial data samples, maybe as means. So let's say mean 1, mean 2, and mean 3. These values, these are they are much like the values like we did in minimum distance classifier earlier. As you know, we implemented the minimum distance classifier in the previous video as well. So this mean 1 resembles to, let's say, the group 1 mean, mean 2 resembles to group 2 mean, mean 3 resembles to group 3 mean. But the point really is, because we do not have group information available, if we have a group, we can compute a mean of it. But we do not have the grouping. That's the whole point. We need to group them. So what we do is we start with some initial random means. We pick some data sample, for example, and call randomly. We pick that point and call that this is mean 1. We pick some other data point randomly and we call, okay, this is mean 2. And similarly, we pick some other data point as mean 3. Mean values need not to be the data points. They can be values other than data points. They may be other than data points. I mean, they need not to belong to exactly the data points. They belong to feature space, but they need not to belong to the data that is available. They may differ, because average of some numbers may not be the number from the numbers. Average may be none of the numbers. It may be different. For example, if you have 2 numbers, let's say 2 numbers 2 and 3, their average is, what's the average of 2 and 3? 2 plus 3 over 2, which is 2.5. And now you can see this 2.5 is not in the original data. So the average values need not to be the training data. It needs not to be the data. But just to start with, just pick the 3 mean values and just consider these are group means. They are representative of group means. Just start by random initializations of the mean. Once you have means available, rest of the story is simply the minimum distance classifier story. You pick each and every data point. You check whether it is closer to mean 1 or mean 2 or mean 3. To whatever it is closer to, just label that at that group. Just labelize it with respect to at which mean it is closest to. After going through all the data set and grouping, and assigning all the data points to one of the groups, depending upon it was closer to mean 1 or mean 2 or mean 3, you will now, at the end of first iteration, you will be having mean 1 group or mean 2 group or mean 3 group. Now what you do is you recalculate the mean 1 from this particular group. You calculate the mean value again. That will be the mean value from the group. Initially we decided the mean value randomly, but now because the group information is available, just compute the mean value from this group. Now compute mean 2 again from group 2, mean 3 again from group 3, and then just discard the previous groupings that were available. Just with new mean values, mean 1 and mean 2 and mean 3, repeat the process and then make the grouping and then re-estimate the means and then discard the groupings and do it again and again until you find out that the mean value that you have now computed and that you have computed in a previous iterations, they are much similar and not changing a lot. Or you can stop these iterations, when you see that the labeling or the grouping information of each and every data point is not changing in the next iteration. There are a lot of things to be considered in k-means clustering. For example, it depends upon the initial choice of means. There are situations in which the algorithm may never stop. The grouping will always stay toggling and stuff like so. So that's why this problem is really a hard problem. It is not a simple problem, but there are heuristics to deal with. There are rules or heuristics to actually initialize the initial mean in a way that it converges faster and so on. Without going into that technical details of in what kind of situations the problem is harder and stuff like so, let's implement this k-means clustering in Jupyter Notebook on synthetic data just to get a look and feel of what actually it can do. So in the next video, I'm going to implement k-means clustering algorithm on synthetic data in Jupyter Notebook. So hope to see you in the next video. Okay, so welcome back. In this particular video, I'm going to actually implement k-means clustering. So let's first make some data set, some synthetic data set. Let's say we have now used this make blobs function several times. Let's say n samples equals to, let's say 500. Let's say the total number of groups or classes. Although I'm actually making a synthetic data for different classes, but basically this is not a classification data. We will not be considering this y value. We will just be considering this x value. So yeah, that's it. Let's generate 3 clusters. Maybe we have cluster standard deviation, maybe whatever the default standard deviation is. Let's work with that. And let's see, plt dot scatter x. Again, you have seen this plot several times. And let's say that's it. So that's the data. That's the data. You do not know what the groupings are. Let me reduce the standard deviation so that you can see and let me reduce the standard deviation. Cluster standard deviation is, let's say, 0.8, so that you can see different groups in a better way. So these are, let's say, 3 groups, and we really want to actually, we do not know that these are 3 groups. Maybe we can have a cluster center, a cluster standard deviation that is a little higher, or maybe more than, let's say, 1.3, maybe that, and maybe like so. And we want to find out the 3 groups in which the data lies, and our goal is to color each group in a different way. So at the end of the day, we are having this data set available, x dot shape, which is 500 data points with 2 features, and we want them to group into 3 features. So first of all, let's randomly pick 3 mean values. Let's randomly pick 3 mean values. And for that, let's randomly pick 3 indices, and then from those indices, just pick the mean values. So let me pick, for example, np dot random dot permutation. Use that. np dot arrange. Let's say that is x dot shape 0. So let's generate all the values, all the indices between 0 and 499. This x dot shape 0 actually returns 500. So what you did is, that's a random permutation of indices. Let me show you the random permutation, or let me show you that. So, or let me show you that. So these are all the random permutation of different indices. I mean, the different indices are there. Just I want to pick the means randomly. What I'm really doing is I will pick the three indices randomly rather. Okay, so let me do it again, this, and then what I do is mean one, let me call it mean one, is my x at row at this, that's my mean one. Similarly, my mean 2 randomly is x at r1. See, r0 can be any index. I do not know that because I have just permuted all the indices randomly. So that's my and it completely depends how you actually pick the first values. So these are my means. If I just tell you the mean, that's my mean. Mean 2 is this, and mean 3 is this. Now I really want to actually supply my original data and actually see the data lies, which data lies in which group. So for that, I may write a function, for example, or maybe I write a function. Let's say define find groups. Yeah, make groups, and this function actually takes input as x, mean 1, mean 2, and mean 3. These values. Okay. So make groups. So what kind of implementation this function should have? First of all, I have to let me just see how can I so first of all, I just subtract x minus mean 1. It will be broadcasted automatically, and then I just let me just compute the distance of all the points from mean 1, and just take the square of the distance and just sum it up, and then we will see how to compare different. So that's the distance of all the points from mean 1. So let me call that distance as, let me call this as d1. That's the distance from mean 1. Okay, now what we do is we compute the distance of all the points from mean 2. Should we do the sum in what axis? All the points axis equals 1. Yes, distance of all the points, so axis must be 1. Yeah, from mean 1. Okay, now what we do is we really Control C, and we just copy that here to compute the distance of all the points from mean 2. That's the distance of all the points from mean 2. And yeah, the rest of the story is same. The distance of all the points from mean 3. Yeah, this and 3. So now basically we have D1, D2, D3 as 3 distance arrays. Next, what we do, we may concatenate these 3 arrays together and find out at which index the minimum really lies. So let me just concatenate these 3. If we can concatenate those, let me concatenate these as np dot, let's say, vertical stack. Should we do it a vertical stack or horizontal stack? Let's do a horizontal stack. And in horizontal stack, I just give these things: d1, d2. We may have to add np.new axis just to make the 2-dimensional things, but let's hope if it works, then fine. Otherwise, we will be adding the np.new axis if required. So we concatenate them. That's D now. D is basically 500 by 3 matrix, and now we find out the indices where basically the minimums they lie. So what we do is np.argmin np.argmin d and x equals, we want to find out the minimum in the first axis, and whatever the index is, we're interested in that index, and then we want to return, for example, this y. Yeah, so if we do that, hopefully it should work. So let's see if it works. We just let me call that and get a y if control C, and a y is there, control V, and what is our y now? That's our y. Oh, it has an error. D argmin, we have an error at argmin. What kind of error? x1 is out of the bounds of the array of dimension 1. So D already is array of dimension 1. What is happening? Horizontal stack. Yeah, maybe we have to do this np dot new access. I guess we have to do that. Np dot new access, and here we have np dot new access. I guess that, and it works. Now if you see the unique values of y, each and every data point it has associated with a group 0 or group 1 or group 2. If I just show you for now what kind of grouping has happened so far, if I just show you that, then let me show you that, and then progressively we will move on, and the grouping should become refiner. So let's see this, and let's say C equals y, and we have C map equals autumn UMN. That's what, oh my god, in just one go it actually, oh that's strange, it just picked the 3 centers in a way that it just actually did the same stuff in just one go. This is unexpected. This is really unexpected. It should have done some errors and stuff like so. But let me change the data set. Let me change the data set. Maybe let me make it as 5. Let me change the data set and see what happens, because it just picked the right centers the very first time. Now, yeah, now there are certain, I mean, this is group 1, for example, this is group 2, and all these, they belong to group 3. So yeah, now you see the grouping is not very fine now. Now what we do is we actually compute the means from different data. So for example, we compute first the index where y equals 0, and we compute the mean 1 as all the x values with index dot mean, and that mean is computed in x's equals 0. Similarly, we compute mean 2 as x. Let me do something fancy here. X as os y equals 1 colon dot mean x's equals 1, and x is equal to 0, sorry, x is equal to 0, and then mean 3 is all x, pick the group, all the values of the last group, and then compute the mean x's equals 0. Once we have all that stuff done, now compute the y again using the same function. So what functions do we have? Make groups, make groups, and it requires what? It requires, I guess, x, mean 1, mean 2, and mean 3, I guess. And now we call that function. Yeah, and see after this what kind of grouping do we have. So let's see. Let's just plot now what happens after this. So let's just plot this. Control V, and yeah, we could not succeed very much, and it looks like we are stuck here. So let's try again. Let's compute the mean again. And is it the very similar than the earlier one, or a little different? A little different, because you can see the red dots here. They were no longer red earlier, but now they become red. Further, there are these yellow points. They were not yellow earlier, but now they are yellow. So what we do now is, again, we do the same stuff, Control X, and we do the same stuff again. And now we'll pick the, let me just make it more smart. Let me just write here y equals 0, and if we do that again, we will be having this stuff, which is, I guess, a little bit improved version of the earlier thing. Then now we again have y. We now have y. We can move back and we can do that stuff, and we may have, each and every time we do again and again and again, and we may have improvements or we may not have improvements. It completely depends upon the initial values. Maybe we go back and set the initial values again randomly, and maybe for example we set the initial values again differently, and we have this thing. So now we have this. Now, just setting the initial values differently, we have this kind of grouping. And if we change, if we just do that grouping again, then we have this kind of structure. Oh, this is great. I guess we have a better grouping now. If we do that again, if we do another iteration, we have this. We may do another iteration, and so the whole point is you do this iteration again and again. You make groups, you compute mean, you rearrange the groups, you again compute the mean, and keep on doing until you get the grouping you want. Here we get the grouping in just a few iterations, but it is possible in k-means clustering, depending upon the initial means, the very initial values of the representatives that you pick. Based on that, it may become longer, or it may become harder, or it's sometimes impossible. So that's it. I just wanted to give you a look and feel of k-means clustering, linear regression, and classification, just implementation from scratch. From now on, we will be using mostly the models or the functions that are available in scikit-learn. So yeah, in the next video, I'm going to talk about the evaluation methods for our model. So given model, what are the ways to evaluate our model? So hope to see you in the next video.